Hey everyone, today I'll show you how to make a simple electromagnet and explain how they work. To make it, you will need a battery, enameled copper wire, a ferromagnetic core like a screw or a nail, tape, an abrasive surface like sandpaper, or in my case a nail file, and washers. When choosing the wire, keep in mind that a thicker wire will create a stronger electromagnet. Mine is on the thinner side, but it will still work nonetheless. First, I'll remove the insulated layer of the copper wire using the nail file. This may take a while. You can check your progress based on the color. It's hard to tell on camera, but what was once orange is turning silver, and that's how you know you're almost there. Okay, right now it looks good enough. Now we just have to do the other side. One eternity later, and we can see the color change. Now it's time to go to the next step. The next step is to wrap the wire around the screw, and the more times you do this, the stronger the electromagnet you'll make.
Right.
So at this point, your screw and wire setup should look something like this, and now all that's left is connecting the washers to the end of the wires to make an easier connection between the wires and the battery terminals. See? Just like that. Now, I'll use the electrical tape to connect the washers to the battery terminal. With this step, it doesn't matter exactly how you do it. You could create a permanent connection between the wires and the terminals and have an electromagnet that runs as long as you have charge in your battery. You could also choose not to use electrical tape at all and just use your fingers to make the connection each time. For my uses, I think it would be best to only make one permanent connection so that whenever I want to turn on the electromagnet, I just have to connect one wire to one terminal. Now, I'll take another ferromagnetic object, which in this case is a washer, to see if it works. And failure! So I took a moment to check the wire's connections to the terminals, and let's try again. And magic! Magic off, and magic! Let's try something else. What? Oh well, I'll find other magnetic objects and we can do more tests. Before that though, let me explain the science behind it all. Now, imagine a wire, or follow along with the one I'm drawing. I chose to only draw the electrons for simplicity. Because it's not connected to a power source, it has no flowing electrons and no current. And just for clarification, current simply means that there's a flow of electrons. Now, what happens if you connect a power source like a battery to the wire and create a circuit? What the battery does is it pushes electrons out of the negative terminal and accepts them from the positive terminal. In other words, there is an electron flow and a non-zero current is created. And it's this current that creates a magnetic field. If electrons were moving to the right like in the image, then the magnetic field will look something like this. So many electronics around us create a magnetic field, like the cable you might be using to charge your phone right now. However, objects like the charging cable create such a small magnetic field that it's almost unnoticeable. What makes the electromagnet much stronger is both the shape and the iron core, which I'll explain in more details in just a moment. So first, I'll explain the what, and then I'll explain the why. The following equation describes the behavior of an electromagnet in the shape of a solenoid, like the one we built. Now, for our purposes, most of these variables don't matter, but I do want you to take a look at the N and the I, which stand for the number of wire turns and the current. This equation tells us that if you either increase the number of turns of the wire around the screw or the current, the magnetic field will increase, or become stronger. But this leads to yet another question. What exactly influences current? We know it's electron flow, but how can you increase that electron flow? It comes down to two factors, voltage and resistance. This relationship can be explained by another formula, I equals V over R, or current is voltage over resistance. Now let's translate to English. Voltage is how much strength a battery has when pushing electrons out of the terminal. Thus, it makes sense that if these electrons are pushed with a greater force, that more electrons will flow total in the wire, which means that there will be a greater current. Now resistance, well, it's kind of in the name. Resistance is how free electrons are when moving through a wire. For example, if there was a greater resistance, think of electrons trying to move through a field, but then there's a lot of brick walls. Of course, it would be a lot more difficult for them to get through. Whereas if it was a field with no obstacles, then it'd be easy for the electrons to get past. So, it also makes sense that with a smaller resistance, there'd be a greater current in the wire. Now as promised, I'm going to explain why a solenoid shape, or wrapping a wire around the screw, creates a strong magnetic field. Imagine that this circle is a wire wrapped one time around the screw. That wire will create a magnetic field, small but real. So if you kept wrapping the wire around the screw multiple times, then the magnetic field of each segment of wire would stack with one another, and you'd have a noticeable magnetic field. The other important part of an electromagnet is the iron core. I mean, why can't it just be a hollow coil? Well, it's because iron is ferromagnetic, so when an electric current is passed through it, it also becomes a magnet. But first, let me explain exactly what is a ferromagnetic material. A ferromagnet has a bunch of opposing magnetic domains. Basically, a ferromagnet has multiple opposing magnetic fields, and because of this, they cancel out as a whole. But if you were to pass a current around the ferromagnetic material, this would align all the domains, and this material would have a magnetic field. So that's it for today. I'll just have a few more tests with the electromagnet in the background while I say the outro. I hope you enjoyed the video, and if you stayed to this point, I sincerely appreciate it. Do expect similar videos in the near future, and I hope I'll see you soon. Enjoy 10 seconds of silence.